Boys and girls, we have question 7. When a certain rocket engine are fired, they will produce a total thrust force of 4.2 to the power of 6 Newton. So in testing, we just test want to fire only, but the rocket is not yet fire into the air. Rocket belum launch lagi ya, kita just nak testing sahaja. So the rocket is held to the launch pad by 6 steel bolts, each of diameter 8 cm. The Young modulus of steel is 2 to the power of 11 Pascal. We are given the Young modulus. The breaking stress of steel is 5 to the power of 8 Pascal. Maksudnya, untuk steel, breaking stress paling maksimum steel boleh resist is 5 to the power of 8 Pascal. So question A, we want to calculate the stress for each bolt during the test. Class, sila buat corrections in your tutorial questions. It's not strain, but it's stress. Okay. B, determine the minimum numbers of bolts that could have been used for testing the engine. So, I try to visualize the problem. We have a rocket. In order to do testing, nak buat pengujianan firing sahaja, belum nak firekan roket. So, kita kena ikatkan roket ni. So, kita ikatkan roket ni kepada launch pad menggunakan 6 biji steel bolt. So, view from top saya lukis macam ni. Ini adalah roket kita. So, saya ikatkan roket tu dengan 6 biji skru. 6 biji skru, 6 steel bolts, okay, to the launch pad. This is the launch pad. So, the diameter of each bolt. So, saya gambarkan dekat bawah ni. So, skru kita tu, this is the bolt. So, the diameter of the bolt is 8 to the power of -2 meter. So, the Young modulus, so this bolt is made of steel. So, the Young modulus of the material is 2 to the power of 11 Pascal. So, the breaking stress, the maximum stress the steel bolt can resist is 5 to the power of 8 Pascal. Okay, so we want to find the stress for each bolt. So, the rocket has a thrust force of 4 to the power of 4.2 to the power of 6 Newton. So, we know that the rocket have a thrust force (4.2 to the power of 6 Newton during the firing. So, we assume this thrust force will be divide equally lah, dibahagi sama rata between the 6 bolts lah. Why? Because kita kan ikat roket tu dengan 6 bolts kan. So, 6 bolts ni, dia akan rasa thrust force ni secara equally lah. So, kita assume lah, dia divide equally between the 6 bolts. So, in order to find the stress for each bolt, I have to calculate first lah. Saya kena kira dulu force for one bolt. Berapa force yang dirasa oleh satu biji bolt tu. So, force for one bolt will be the thrust force divided by the numbers of the bolt. So, 4.2 to the power of 6 Newton divided by how many bolts? We have 6. So, I'll get the force that experienced by one bolt is around, you may pause the video to do the calculations. So, it should be around 0.7 to the power of 6 Newton. Okay, so we get the force experienced by one bolt. And then only we can find the stress for one bolt. So, the stress of 1 watt will be the force experienced by the boat divided by the cross-sectional area of the boat lah. So force 1 biji boat tu adalah 0.7 to the power of 6. How we find cross-sectional area? So the cross-sectional area, boats tu adalah bulat. So the cross-sectional area is pi r squared, whereby the r is diameter divided by 2. Diameter divided by 2, so we are going to have pi. So diameter is 8 to the power of negative 2, so divide by 2, so 8 to the power of negative 2, we have to divide by 2, then squared. Okay, then pause the video to do the calculations. You should get around 1.39 to the power of 8 Pascal. So this is the stress experienced by each of the boats during the test firing. Okay, so we done question A. Question B, we want to determine the minimum number of boats that could have been used for the testing the engine. Okay, so class, kalau if we are engineer, maybe we are thinking of we try to minimize the numbers of boats yang boleh digunakan untuk pegang roket tu masa test firing. So kita nak carilah minimum numbers of bots yang kita boleh gunakan. Alright, so mungkin kita tidak perlukan sampai 6 biji. Jadi kita nak carilah berapa bilangan minimum bots yang kita boleh gunakan. So for question B, we assume the minimum numbers of bots used is N. So kita nak dapatkan N ni lah. But we have to bear in mind, kita perlu bear in mind. So in order to find the minimum number of the bots, kita kena ingat nak pegang lagi. We still want to help the rocket on the launch pad. Kita masih nak pegang roket tu. Jadi kita kena make sure the stress of each bot cannot be more than the braking stress lah. Dia tak boleh lah lebih daripada braking stress. That can be yang boleh diterima oleh steel. Kalau dia lebih dari braking stress, nanti bots tu pecah, nanti kita dah tak boleh nak pegang roket tu. Okay, so the stress that experienced by each of the bot must less than the stress of the braking lah. The braking stress. So stress of one bot will be less than the value of braking stress given in the question is 5 to the power of 8 Pascal. Okay, 5 to the power of 8 Pascal. So stress for one bot will be the thrust force, the thrust force created by the engine of the rocket divided by the numbers of bots we use, okay, over the cross-sectional area of the bots lah. Sebab stress adalah force over area. So force untuk one bot adalah the thrust force divided by the numbers of bots kita guna lah. So this value must less than 5 to the power of 8 Pascal. Okay, so nilai tu mesti kurang dari braking stress. So thrust force engine rocket 4.2 to the power of 6, dan kita kena bahagi dengan numbers of the bots used lah, barulah kita dapat force untuk satu bot. Okay, over the cross-sectional area. Cross-sectional area adalah pi r squared. So R adalah diameter bahagi 2. So diameter of the bots is 8 to the power of negative 2 bahagi 2 kuasa 2. So this value less than 5 to the power of 8 Pascal. Okay, so kita kena selesaikan secara mathematics. We rearrange. So we want to find for the n. So we have 4.2 to the power of 6 over n. Here will be 5 to the power of 8 multiplied with pi. Then 8 divided by 2, 4 to the power of -2 squared. Okay, so I'll get 4.2 to the power of 6 over n. Here I solve it, I will get 2.573 to the power of 6. So in order to get the minimum numbers of both, so saya susun balik, ni bawa ke bawah, 2.573 to the power of 6 less than n. Okay, so teruskan matematik lagi. So I solve this one, I'll get around 6.7 less than n. So it means that the minimum bot use, the value of n must be greater than 1.67. Greater than 1.67 means the minimum numbers of n will be 2. Okay, so kalau you gunakan dua bot untuk pegang roket tu pun dah boleh, di mana dia masih boleh pegang roket tu, okay, during the test firing. Then we solve question B.